These are the notes from section 9.3 and 9.5. It's on geometric sequences and series. A geometric sequence is a list of numbers, a sequence in which the ratio between consecutive terms is constant. So something like 2, 6, 18, 54. 2 times 3 is 6, times 3 is 18, times 3 is 54. The ratio between consecutive terms. 6 is to 2 is the same as 18 is to 6, is the same as 54 is to 18. That common ratio is the ratio between consecutive terms. Example 1 asks us, is each of the following sequences arithmetic, geometric, or neither one? If it's arithmetic or geometric, we are asked to find the common ratio. Part A, we have 6, negative 24, 96, negative 384. An arithmetic sequence, we're adding or subtracting the same thing over and over again. Because this goes down and then back up, it cannot be arithmetic. Check geometric. 6 times 4 gives me negative 24. Times negative 4 gives me 96. Times negative 4 gives me negative 384. It is geometric with a common ratio of negative 4. Part B, we've got 8, 20, 32, 44, plus 12, plus 12, plus 12. It is arithmetic. Common difference is 12. The explicit formula that'll give us a specific term from a geometric sequence is a sub n is equal to a sub 1 times r to the n minus 1. We start with the first term, and we're multiplying by r over and over again. To get to the second term, we only multiply by r one time. To get to the third term, we multiply by r 2 times. To get to the fourth, 3 times, and so on. So it's to the n minus 1. Here we are asked to find the 19th term in each sequence. 11, 33, 99, 297, ... First thing we need to do is decide if this is arithmetic, geometric, or neither one. 11 times 3 times 3 times 3. So it is geometric. We are looking for the 19th term of a geometric sequence. We start with the first term 11. We are multiplying by 3. To get to the 19th term, we need to multiply by 3 18 times. 11 times 3 to the 18th gives us a giant number. That is 4,261,625,379. So notice, because we're multiplying by something over and over again, these numbers often get pretty big pretty quick. Part B, 2017, 14, 11, 8. Hopefully we can recognize this as arithmetic. Minus 3, minus 3, minus 3, minus 3. Use the arithmetic sequence formula, which is the first term, plus the common difference, negative 3, times 1 fewer than the number term I'm looking for. So to get to the 19th term, I'm going to subtract 3 18 times. And we get negative 34. The geometric mean of two numbers, we take the square root of the product of the two numbers. The geometric mean will give us the missing term of a geometric sequence. So here we are asked to find the missing term 20 blank 80. 20 blank 80. So we want to take the product of the numbers, 20 times 80, and then take the square root. Gives us 40. Notice times 2 times 2. So So multiply the numbers together, take the square root. That will give us the missing term of a geometric sequence. Technically, it could be negative 40 as well, times negative 2 times negative 2. Section 9.5 is on geometric series, which is simply the sum of a geometric sequence. The formula for a geometric series is right here. S sub n is equal to a sub 1 minus a sub 1 times r to the n, all over 1 minus r. We were asked to use the formula to evaluate this series. Obviously, we could just add up these terms, but let's make sure we understand how to use the formula here. We take the first term, 6 minus 6, times the common ratio, times 2 times 2 times 2, to the n, I have 5 terms, divided by 1 minus r. The common ratio is 2. When you type it into the calculator, make sure you use parentheses around the numerator and the denominator. I would recommend typing it all in as one step like that, and we get 186. Another way you could type it in, if you push alpha y equals, this first one that pops up is number 1, numerator over denominator. And now you don't have to worry about the parentheses because it's written as a fraction instead of a division problem. Either way, we get 186. Let's try this one down here. Find the sum of the first 8 terms. 1,500, 250, dot, 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 times 1/2, times 1/2. So it's geometric. The sum of the first 8 terms is the first term minus the first term times the common ratio to the n, all over 1 minus the common ratio. So we've got 1,000 minus 1,000 times 1/2 to the 8th divided by 1 minus 1/2. Uh, 1992.1875 if we are allowed to use decimals. If not, we can change that to a fraction by going to math. Number 1, well, let's take out the 1992. So 1992 and 3/16.